So this next topic is angles of polygons. So we're going to start with the interior angle sum. The sum of the degrees in any polygon can be determined by the number of triangles that can be drawn within the polygon. So we're going to try and complete this table below and try to find a pattern to find the sum of the degrees in any polygon. So first off, we have a triangle. And by the way, this is in your notes within your homework, so you can take notes on your own paper, or you can just reference the homework and you'll see that they are there, or it is there. So we have a triangle. The number of sides is 3, and obviously there's only one triangle. We already talked about the sum of the interior angles in the triangle. We know it's 180. In terms of a quadrilateral is a 4-sided figure. And the number of triangles, we have 1 triangle and we have 2. So there are 2 triangles. And if each triangle is 180 degrees, that's 180 plus another 180. That means there's 360 degrees in a 4-sided figure. Next, we have a pentagon, which is a 5-sided figure. And I always remember that because you hold a pen with your hand, and your hand has 5 fingers or 5 digits. So it's a 5-sided figure. We have 1, 2, 3 triangles. 180 plus 180 plus 180, we're going to get 540. We have a hexagon. That's a 6-sided figure, and it has 1, 2, 3, 4 triangles. So if we do 180 times 4, you are going to get 720 degrees. Now for a heptagon, octagon, nonagon, there is no picture here, but that's a 7-sided figure, 8-sided figure, a 9-sided figure, and a 10-sided figure. So that means if you can see this pattern here, 1, 2, 3, 4. So this is obviously going to have 5 triangles, 6 triangles, 7 triangles, 8 triangles. So if you do 180 times the number of triangles, you're going to get the sum of the interior angles of that figure. So 180 times 5, you're going to get 900. 180 times 6, you're going to get 1080. And 180 times 7, you're going to get 1260. And 180 times 8, you're going to get 1440. So this chart is always good to have nearby to be able to reference it whenever you're solving problems. Then the sum of the interior angles S can be found using the formula S equals n minus 2 times 180. So if we want to check this formula, we could do it for a triangle. So the number of sides in a triangle is 3. So there's 3 sides in a triangle, which means n is going to be 3 because it says n represents the number of sides of the polygon. So we're going to do S equals 3 minus 2 times 180. So we're going to have S equals 1 times 180, and 1 times 180 is 180. So we know that that works. So the interior angle of a regular polygon is one in which all sides are equal. Therefore, all angles are equal. To find the measures of an interior angle in a regular polygon, we're going to use the formula S over N, where S is equal to the sum of the interior angles and N is equal to the number of sides in the polygon. So let's try a couple examples. Number 1 says find the sum of the interior angles of a 15gon. The sum of the interior angles of a 15gon, which means it is a 15-sided figure, right? So we're going to use this first formula because it says the sum of the interior angles. So we're going to use this one. So we're going to do 15, or S equals 15 minus 2 times 180. Because 15 is the number of sides we have. So that's going to be 13 times 180, which means that's going to be 2,340 degrees. Number 2 says find the sum of the interior angles of a 21gon. So that's 21 sides. So we're going to simply do S equals 21 minus 2 times 180. Or 19 times 180, which equals 3,420 degrees. Number 3 says, what is the measure of each interior angle of a regular pentagon? So we're going to use this formula, where S is the sum of the interior angles and N is the number of sides. So it says Pentagon. Pentagon is a 5-sided figure, so we're going to write 5 sides. And if we go back to our chart that we were using earlier, we see that a 5-sided figure, the sum of the interior angles is 540 degrees. So we're simply going to do 540 divided by 5, and that is equal to 108 degrees. Number 4 says, what is the measure of each interior angle of a regular 18gon? So that's 18 sides. Now we don't have this in our chart, so we're going to use the first formula in order to figure out the sum of the interior angles for an 18-sided figure. So we're just going to do S is equal to 18 minus 2 times 180, which means that's 16 times 180, and that is equal to 2,880 degrees. So then we're going to do 2,880 divided by 18, and that's going to give us 160 degrees. Now we're going to talk about the exterior angle sum. So the exterior angles are always supplementary. Remember, supplementary means that it adds up to 180 degrees. So it adds to 180. It's supplementary to their adjacent meaning next to, the adjacent interior, and interior means inside. So it's supplementary to the adjacent interior angle. On the polygons below, find the measure of each exterior angle along with the sum of all exterior angles. So what we're going to do is look at each angle and then subtract it from 180. So 180 minus 79, we're going to get 101. 180 minus 40, we're going to get 140. 180 minus 61, we're going to get 119. And if you add all of these, you're going to find that that is equal to 360 for this triangle. Now the exterior angles of a quadrilateral, we're going to do the same thing. 180 minus 76, we're going to get 104. 180 minus 89, we're going to get 91. 180 minus 71, we're going to get 109. 180 minus 124, we're going to get 56. If you add all these up, it's going to be 360. Going on to a pentagon, 5-sided figure. 180 minus 121, we're going to get 59. 180 minus 87, we're going to get 93. 180 minus 130, we're going to get 50. 180 minus 104, we're going to get 76. 180 minus 98, we're going to get 82. And it's still going to add up to 360. If you add 82, 59, 93, 50, 76, you're still going to get 360. Now, last one is a hexagon. This is a 6-sided figure. 180 minus 129, you're going to get 51. 180 minus 124, you're going to get 56. 180 minus 112, you're going to get 68. 180 minus 123, you're going to get 57. 180 minus 117, you're going to get 63. And 180 minus 115, you're going to get 65. Add all of them up on the outside, and you're still going to get 360 degrees. So we can make the conclusion that the sum of the exterior angles of any polygon, and remember it's exterior, so the sum of the exterior angles of any polygon is always 360 degrees. No matter how many sides it has, it's always going to be 360 degrees. Now let's use this conclusion to solve some of the next problems. So number 5 says, what is the measure of each exterior angle of a regular hexagon? So a hexagon, we know that is a 6-sided figure. 6 sides, which means 6 angles. So we're going to do 360 divided by 6, because all of the exterior angles in any polygon is going to add up to 360. So we do 360 divided by the 6 angles, and that means they're each 60 degrees. Number 6, what is the measure of each exterior angle of a regular 24gon? So that's a 24-sided figure. 24 sides means 24 angles. So we're still going to do 360 divided by 24, which means each of them are going to be 15 degrees. Now number 7 says if the exterior angle of a regular polygon measures 12 degrees, how many sides does the regular polygon have? So now we're actually looking for how many sides it has. So we know the exterior angles add up to 360 degrees. And if each angle is 12 degrees, we just have to divide them. And we'll see that there are 30 sides. So it's a 30gon. Number 8 says if the exterior angles of a regular polygon measures 40 degrees, how many sides does the polygon have? So we're going to do 360 divided by 40 degrees, and that is going to give us a 9-sided figure. So there are 9 sides. Now here I'm going to write the different formulas that you are going to be using to solve these problems. This is, again, also in your homework. You can take notes on your own paper or reference the homework. So the sum of the interior angles of a polygon, as we said before, S is equal to n minus 2 times 180, where n is the number of sides. The interior angles of a regular polygon is S over n, where S is the sum of the interior angles and n is the number of sides. The sum of the exterior angles of a polygon is always going to be 360 degrees. The exterior angle of a regular polygon, if you're trying to find how much each angle is, you're just going to do 360 divided by n, where n is the number of sides. And if you're trying to find the number of sides of a regular polygon, you're just going to do 360 degrees divided by the exterior angle. Now let's try a few problems. So this problem says find the value of x. So this is a 4-sided figure. And if we look at our chart, we're going to see that a 4-sided figure, the number of sides is 4, and the sum of the interior angles for a 4-sided figure is 360 degrees. So we're going to use that in order to solve for x. So we're simply going to say 79 plus 55 plus 110 plus x is equal to 360. Now, if you add up 79 plus 55 plus 110, you're going to get 244. So if you have 244 plus x equals 360, you can subtract 244 from both sides. and you're going to get x is equal to 116 degrees. Now, if you ever want to check your answer, just plug x back in, add up all of the angles, and see if it adds to 360. If it doesn't add to 360, then you know your answer is wrong. This next one, this is a 1, 2, 3, 4, 5, 6, 7-sided figure, and we know a 7-sided figure adds up to 900. So we're going to do 140 plus 136 plus x plus 142 plus 150 plus, this is a 90-degree angle, so plus 90 plus 148 is all going to be equal to 900. So if you look at your chart, you're going to see that a 7-sided figure, the sum of the interior angles is 900. So combine all of your numbers, all of your like terms, and you're going to see that when you add them up, it's going to be equal to 806. So we're going to have 806 plus x is 900. Subtract 806 from both sides. And you're going to have x is equal to 94 degrees. Again, if you want to check your work, add 94 plus all of the other angles. And if it adds up to 900, then you know you're correct. So this one is a little bit different just because we're dealing with exterior angles, exterior meaning outside. So remember that the sum of the exterior angles is always 360, no matter what polygon it is. So we're going to take all of these exterior angles and we're going to say 5x plus 12 plus 10x minus 37 plus 9x plus 1 is equal to 360. Now we can combine like terms, so we're going to put our x's together, 5x, 10x, and 9x. That's going to give us 24x. And if we add up all of our constants, we're going to have 12 minus 37 plus 1. So we're going to get minus 24. And that's going to be equal to 360. Let me make that darker. So now we can just add 24 to both sides. That cancels. And we have 24x is equal to 384. Now if we divide 24 on both sides, we're going to get x is equal to 16. Be careful because this question did not ask for x. It asked for the measure of angle BCA. Angle BCA is actually this angle. It's one of the interior angles. So it's this angle right here. And you might be wondering, well, we don't have an expression to represent BCA, but we do have an expression on the outside. And remember, the sum of these two angles right here, they are supplementary, which means they add up to 180. So what we can do is put this 16 here, and whatever we get, we subtract from 180 to get our interior angle. So if we do 10 times 16, that's 160. Subtract from 37, you're going to get 123. And if you subtract 123 from 180, you're going to get 57 degrees. Now remember, in the homework problems, it might not look exactly like this one, but you should be using the formulas in that table. You should be using the chart with all of the formulas and first figuring out how many sides does the figure have. Once you figure out the number of sides, you can determine what the number of the sum of the interior angles is, and then set up your equation equal to that sum, and then solve for x. Next up is going to be properties of parallelograms.